So this video is really part 2 of a 3-part rebuilding video for the 8L90. And in this video we're going to go through and reassemble the transmission and do some clutch pack clearance measurements and basically get this unit back together. Now the one before this was the disassembly video in case you didn't see it, and the one after this is also covering the valve body, kind of going in deep into the valve body assembly and learning how everything works inside the valve body and going through and looking at some modifications that some of the aftermarket companies are doing to these transmissions. So now I'm going to go through and put this transmission back together. I'm not going to follow the conventional, typical way of doing things where you'd strip the transmission down to its parts and pieces, clean everything up, inspect it, order parts, and then reassemble, because this is a lab unit and it's just going to go back together the same way I take it apart. Basically, I'm just going to, as we go to put something in, we're going to go through and study it and inspect it and then put it in and then move on to the next piece. So it's not typically how you'd rebuild a transmission, but that's just how we're going to do it here. First one that we're going to go through is this 1235R. This is that holding clutch. This is the part that's pretty much part of the tail housing of the transmission. Here's the apply piston that we have here, and we've got to compress this piston here a little bit to get the snap ring out so we could disassemble it. There's going to be some seals in there that we would inspect and replace. This clutch would normally fit on the back of the transmission. You'd bolt it to it. The fluid pressure actually comes through this passage down into that clutch housing. It goes in through this passage right there, and that gets behind this piston and lifts the piston up to apply it. This passage right here actually gets in between the piston and this spring retainer. And they fill that with fluid to keep this piston released when it's not supposed to be applied. So what we'll do is we'll use our spring compressor and compress that spring retainer down just a little bit to get my snap ring out. It's a pretty thick snap ring. It's kind of got rounded edges on it too. This is the spring retainer, and you can see we have a couple seals. We have an outer D-shaped seal, we have an inner D-shaped seal, and then an O-ring. Those fit down in there. I'm going to gingerly pry up to get this piston to come out of the bore. So here's our piston. Now there are a couple bleed orifices in there. You see these two bleed orifices. If I flip it over, you see only one passage. That passage is for when fluid pressure gets in through this hole, gets behind the piston, lifted up. This passage right here will bleed the air out so that there's no air trapped in this. Now this other bleed passage comes across from this inner hole, and that's a way to bleed the air out from the fluid that they feed between the spring retainer and the piston. We also have a O-ring right here located in this housing, a needle bearing to support that output shaft, and then of course a seal that you'd want to replace. This kit right here is from Precision International. This is a 2015 to 2022 8L90 kit, and it comes without any molded pistons, which there's only one molded piston in this transmission anyway. And let's take a look to see what they include. They were kind enough to give me a couple of these kits, which I really appreciate, because being a school, we aren't making any money off of these transmissions. But you can see right here is that extension housing gasket that we've got, some various oil seals. It's nice they give you the plastic thrust washers, the ones that go for the pump and in between some of the gear sets. So not all kits include thrust washers like this, but these plastic thrust washers could be a wear item, so it's nice that they provide that in the kit. It's also nice that they include these aluminum bolts that is listed in the service manual, that when you take these out you have to replace them. So they're provided in this kit, which is excellent. And they also provide these check balls, and looks like some clips for your valve body. And there's that bridge seal. So It's real nice that they include these check balls. These, if you know much about these GM transmissions, especially the ones that use these plastic check balls, they have a tendency of shrinking, getting smaller, and sometimes it's hard to see by the naked eye, so you got some replacement check balls here in this kit. Some small parts, some of the O-ring components, and some plugs. Even that plastic thrust washer that goes with the sun gear. That might not be a wear item, but it could be something that could accidentally get broken or damaged. So it's nice to have that included in the kit. Look at that. It even has a new roll pin. It's got a lot of these parts that are nice to have on hand. They, like I said, they might not have wear, the ones that you take out, but some of these things are fragile and they break, and it's nice to have a part that you can replace it with. Got some more oil seals depending on the application, from pumps to output shafts. Of course, got a new oil pan gasket and the little locating tabs there to kind of keep it attached to the oil pan. We've got our front cover gaskets and a variety of valve body paper gaskets. A lot of O-rings. These are for the valve body solenoids. All your Teflon seals for your stator support and your input shaft or turbine shaft. This is nice. They include the pulse dampeners that are going to go into the valve body and replacement springs. Now these are areas that wear out a lot, so you might be putting in a TransGo or a Sonnax kit or something to replace these pulse dampeners, but if they're not worn out or if the bores are not worn out excessively, you've got new pulse dampeners right there in this kit. It's also nice that they label these different kit parts. You can see this one's for the 2, 3, 4, 6, 8 clutch. They give us replacement snap rings for the majority of this transmission, so it's nice to know that we've got snap rings, those big thick O-rings that go around that pump cover, 2 different sizes of those, and more piston gaskets. Here's the 1, 3, 5, 6, 7, and the 2, 4, 6, 8. Here's the 4, 5, 6, 7, 8. And the one that we're going to need right now is the 1, 2, 3, 4, 5. Lastly, we've got these pump parts. Depending on what model year transmission you've got, it's going to determine which gasket you end up using. They did a change in like 2019, late 18 or something like that. So this kit right here is the Precision kit, and I also have an OE factory, bought it from General Motors kit, and we're going to see how it compares with the parts and pieces. This kit right here is a General Motors. We got it from the GM dealership, and part number is 2404-5157. Now one thing that's nice about it, and of course I bought this model dependent, it came with the new bonded spacer plate. So these, I wouldn't have to do any scraping of gaskets or stripping of any of the paper gaskets. It actually comes with 2 new plates. And a new rear gasket, of course, and a front cover gasket. It included the filter in this kit. Has some paperwork that comes with it that basically has some instructions. And so that kind of stuff. We'll talk about that separately to see if there's any updates or changes that they had you do in these kits. As far as the seals are concerned, we've got that big thick pump cover gasket. We have the clutch gaskets listed. They do kind of list it out similar. It says 2017 and prior, 2, 3, 4, 6, 8. They package it a little different, but they include the check balls, the roll pins, the aluminum bolts, Teflon sealing rings, oil pump covers. It looks like they have the early and late design. And there's a seal in there. They also include the snap rings in their kit and some pump sealing parts and gaskets. So the GM kit did come with some of these spacer plates and a filter, which is nice, but I did order that based off the VIN as opposed to the Precision kit that covered 2015 to 2022, such a wide range. It's going to accommodate different units, and as well things like the filter, if it changes its design, well, that kit still works. You just order whichever filter you need. But it looks like the parts and pieces are pretty much the same, aside from the filter and then the bonded spacer plates. So I'm going to go ahead and change the seals on this 12345R, the C2 clutch. I've already cleaned this up. Now I will tell you, I'm going to word to the wise. I don't know if it's just if my solvent tank is contaminated or if these seals are just super prone to it, but I cleaned these off in solvent, gave them a good blow dry, and now that I'm taking these things apart, these seals are expanding and swelling to the point where I cannot reuse them. I have to change these out. So like I said, I'm going to have to look into that. I don't know if it's my solvent is old or not, but if you notice, this piston has a big old lug right there, and that lug fits in this spot right there. Now that this piston assembly is together, if I air check this at this point, I got to be very careful because there's nothing for that piston to work up against. Normally you don't want to air test things unless you have a clutch assembly for that piston to push up against, because we can overextend it. But if I just kind of gingerly bring air in there, you can see it goes up okay. This other side won't have any movement because it is basically on the spring retainer side. But I can go through. Now I can plug off the air bleeds, put some air pressure in there and make sure things seal. I could do the same thing with the apply piston. That way I know I got a good seal. So the next step is putting this back onto the transmission with a new gasket and torquing it down. Then I'm going to build my clutches in there, put the snap ring in, and I got to go through the process of checking clutch pack clearance. And that process is kind of unique. What they're going to have us do is put a certain amount of pressure on those clutches, zero our dial indicator, and then relieve that pressure, and then use air pressure to stroke the piston, and then reapply the pressure and measure how much clearance or how much movement that piston accomplished, or that clutch accomplished. And then we'll compare that to specs, and depending if it's right or wrong, is going to determine what size snap ring we need to use. Now it's time to put some of these gear set parts in here. The first part we're going to put in is our output shaft, and there is a Torrington bearing that separates the output shaft from the case. And there are a couple ways that you can install Torrington bearings. If you take a look, the way these are designed, the inside race, what I like to call the inner race, wraps around the inside, and the outer race on a Torrington bearing wraps around the outside. So these are designed to fit either snugly with a shaft, like if this fits snugly around the shaft, you lay the parts down in the shaft and it would rest on that part and kind of wrap up around the inside. But if you see like on this one, it's very loose around that. So it's probably designed to fit into a machine pocket. And if there's a machine pocket on a part, the pocket is designed to kind of center and hold the outer race. It might be hard to tell, but this is a machine pocket down here at the bottom of the case. So that outer race is going to fit nice and centered around that machined little groove or pocket for that bearing. The next parts that we put in are this output gear set, this output carrier. And it could be easy to forget to put the sun gear in. That goes like that. And it could also be easy to forget to put this Torrington bearing. Now this Torrington bearing has kind of a raised lip around it, and that raised lip goes towards the sun gear. If you look down in there though, it looks like it could also fit in the output shaft. And quite honestly, it'd probably work okay that way, but it did come out with that raised lip towards the sun gear. So I'm going to go ahead and put a little bit of TransGo on there, glue that towards the sun gear, mesh this all in there, and I'm going to position this transmission horizontal to make it a little easier to lug that all in. All right, simple as that. Now we got that installed. Next we put in this rear internal third planetary, there is a Torrington bearing that's on the output gear that rides on this side, so it's already installed. It's kind of a snug fit on that output gear set. And then we also have this Torrington bearing that lives on top of it. This has also got that tone wheel that we have so that our speed sensor can measure that. Now we can put our internal gear in, and it has the lugs for the C2 clutch assembly, that 1, 2, 3, 4, 5 R clutch. So once we get this in there, we can install our clutch pack, and we can do our clutch pack measurement. So the 1235R snap ring measures about 90 thousandths of an inch for the unit that we have. If we look at how this is constructed, we've got a wave plate, 3 frictions, and 3 steels. The first steel is a thick apply plate. Then we go friction, steel, friction, steel, friction, and then the backing plate. As you can see, these steels have hot spots on them. Normally we would not use this, but this is a lab unit, so we're going to use it anyway. So now I got the 1235R clutch installed there, the snap ring's installed, and we're ready to do this clutch pack clearance measurement. And the procedure for this is kind of interesting. They have us put 80 pounds of force on this clutch pack to kind of seat it down. And we mount a dial indicator on there, and we zero that dial indicator out in that position. Then we release that 80 pounds of force, and we apply 50 pounds of air pressure. That 50 pounds of air pressure is going to lift that piston up and compress that clutch. And then I reapply that 80 pounds of force, and then I look at my dial indicator to see how much total movement I had. And based off of that, we're going to determine whether or not we've got the proper clutch pack clearance. If it's wrong, we'll select a different thickness snap ring to achieve the proper clearance. Now, there are special tools, and some of these special tools are on back order. You can't even get them. And but you know, the beauty of being in a transmission shop, and this is an old 4L60E drum. This thing is used for so many different applications. This is a broken one, a common part that snaps off. But man, this works in so many different applications throughout the transmission shop as a tool. And also, I've got a little homemade force gauge. The force gauges are only about $150, but this one works well. What it is an 1.125" bore, and I just machined a bore 1 1/8" and a piston, and I put a couple O-ring seals on it, and I found an old AC gauge from an air conditioning gauge set. And basically when I apply pressure on it, if it's 1 1/8", that creates 1 perfect square inch of surface area. So if I put 80 pounds of force, I'll see the gauge climb 80 psi. So that's my little homemade force gauge. I will buy one eventually, but now this tool I did have, and this is what we'll go through, and it's actually what they call for in the service manual, but this lays across the bell housing, and I'm going to use some welding clamps to clamp that down, and then I can screw this nut down to apply force on these parts. There's nothing to say that if you didn't have this, maybe you've got a bar, a metal bar with a hole and a, tapped and threaded just to go across. That's something that's pretty common. This also right here, these are common. They break off. The 4T60s would shear off the end of these 4th clutch hubs. Well, I've saved these. They call them cookie cutters sometimes. And these work well for different tools. We use that in a few different instances on this transmission. Another thing I had to make is getting 50 psi to go into that passage is pretty tricky. I could pull that bolt out and go in through there, but I'd still have to plug this passageway off. So I basically just made my own adapter out of a chunk of aluminum that where we can thread that into there, tighten it up, and I can plumb or put through some tubing. I could put 50 psi into this little circuit and leave it on there. Now, I do know a lot of shops that have gone through and rebuilt some of these transmissions, and they just don't check the clutch pack clearance. Now, I think that's probably okay if you've got hard part damage, but if you have any shifting issues where there's a flare or a bind or a shift quality complaint, you're probably going to want to make sure your clutch pack clearances are set correctly, because on those clutch-to-clutch type transmissions, that is kind of critical. It's critical to have the clearance set right, because the volume of fluid that it takes to stroke a piston is all determined by how far that piston has to travel. And if that piston travels off, it's going to throw off what their adaptive tables are, and it's going to make the transmission potentially shift crummy. I'm going to place that broken 4L60E drum in there. That sits real nice right on top of that backing plate. I'm going to rest my broken, stripped 4T60 cookie cutter, 4th gear hub in there. Go ahead and use my welding clamps to attach this crossbar. Now I'm going to place my load gauge in there. And my load gauge is already reading like 20 psi. So if I want 80, I'm going to have to go up to 100. You can see I could do that by hand. It's the power of leverage there with those threads. Now I am kind of lucky. I've got some dial indicator extensions. So that was able to get me high enough up there to be able to see my dial. So with the 80 pounds of force, it only compressed it about 5/1000ths of an inch. But I'll go ahead and zero my gauge at that point. I went ahead and put my dial indicator more towards the edge of the drum that I'm using to push on, so that way there's little to no deflection that's occurring in that drum. So now I've got a little regulator here that I can set to 50 psi, and we'll go ahead and pressurize this clutch at 50 psi and see what kind of clearance we have with 80 pounds of force on it once it's stroked the piston. So you can see it went about 97 thousandths of an inch. Now we do need to put our 80 pounds of force back on it though. I got my 80 pounds of force, but you can see that clutch pack clearance has not really changed much at all. So it looks like this has about 95 thousandths of an inch or so of clutch pack clearance. So it's supposed to have between 37 and 72 thousandths of an inch of clearance. Now, you guys saw the heat marks that were on that steel. I assume that the frictions are probably worn down a little bit on this too. So I would probably say that you'd want to replace these frictions and these steels, and then this measurement might be a little bit closer to where it's supposed to be. Now, I think I'm only at the second thickest snap ring that's in there. There's at least 3 more thicknesses that are thicker, so for some reason, if this was the true measurement, even with the new clutch pack in there, every snap ring grows about 15 thousandths of an inch in thickness, and we're roughly 20 thousandths of an inch away, so if we upped it 2 sizes, that would decrease our clutch pack clearance of probably about 30 thousandths of an inch, which I'm sure would get us within spec. But like I said, in this situation, we'd want to have new steels and frictions on that clutch because those steels show those heat marks. So we could just assume that those frictions maybe have worn down a little bit. So this next clutch assembly is the 1278R. And this is the only one that has a molded piston in this transmission. So we don't have to go through and find a seal for it. If we suspect an issue with this, we would go through and replace that piston. So looking at this 1278R clutch, we have our thick backing plate. We've got 4 frictions, 3 steels, and this is an apply plate. It's a little thicker than the other steels. And we have a wave plate. And then of course our clutch apply ring or piston and our return spring. The return spring was redesigned in 2019, so it's a little different. I don't have a unit to show you, but apparently that's one of the things they've changed. So now these clutches and steels, you could see they had a little slippage going on there, so I would not want to normally reuse these. Before I put my 127AR clutch in, I'm going to go ahead and lay my Sun gear assembly down there. Now the Torrington bearing rides up against the surface, but you can see it's right there on my internal gear, and this Sun gear is going to rest on the Torrington bearing that's further deep down inside there in the planetary gear set. Now I'm going to go ahead and start with the thicker backing plate there. Now this apply plate is a little bit different. It's a little thicker. And they also position these lugs a little different. There's a little double tooth that normally went with the steels right in this location here. It's actually going to be in a different spot. I don't know if they do that just to alert you, to let you know that this is a different steel because it is a different thickness, and it goes into a different spot. And now here with the apply piston and the return spring, and it goes dish facing down. And then I have my 127AR piston assembly and housing. That lug right there fits into this notch. So it's hard to tell, but there is actually no clearance for a snap ring. We have to compress that return spring a little bit. So we'll go back to our 4L60E drum, let that grab onto that piston housing. We'll use a crossbar here and my 4T60E broken 4th hub cookie cutter. I'm going to use my welding clamps to hold everything in place. You want to air check these with 30 psi. You don't need much pressure. You will expect to hear a leak because there are air bleeds. Sounds pretty good. We're at that point in this process where it's time to go through and build these input drums. We've got the C4 and C5 and the C3. We're going to start with the C4 and C5 and see what they're all made up of. Starting with this C4 clutch, we've got a wave plate, an apply plate, 4 frictions, 5 steels, and then a backing plate. These are adjusted by a selectable snap ring. With the C5 clutch, there's a wave plate, 4 steels, 4 frictions, and a backing plate, and a selectable snap ring. These snap rings are the same size, but the C4 clutch used an 85,000 snap ring, and the C5 clutch used 100,000s. Now, in order to take these pistons out, we need to compress the piston return spring. Now, to compress this, I use this modified cookie cutter that you'll see me using in a bunch of different spots. And I leave myself a little snap ring opening there. And I got to fish this little spacer that I had to cut off of another shaft, but you just have to push this thing down about 1/8 of an inch. Not too far, just enough to give you room to get that snap ring out of its groove. Now, if you have this little special tool here that we'll end up using to air check this and to check the clutch clearances, you can use it to also pop the piston out of there once you remove the spring. This piston that separates the C4 and C5 clutch might not come out, so you have to get in there and kind of pull it out. There's an O-ring that keeps it kind of tight in there. but you can lift it up out of there with a pick. Notice that these little notches right here are facing the bottom of this piston, and whereas these cutouts are facing down into the drum. So these cutouts are facing down, and then these like end notches here are facing up. Or another way you can look at it is that little raised section right here on the inside, that faces down, and you can see it's kind of tapered there, and that's facing up. Looking down in there, you can see we've got another snap ring, so we have to go through and compress the outside of this, get it down enough to get that snap ring out of its kind of captured groove there. And to do that, I just basically have this shell that I cut basically a little bit more than 1/3 of it out, so that way I can push down on it, compress that piston, and get that snap ring out of there. Just push it down until you got enough room to get your snap ring pliers in there and remove that snap ring. You can either use air pressure to pop that piston out, or if you have a hole in your bench, you could do this with the other piston as well. You kind of slap it down in there and that'll pop it out. This is that C4 piston. It's actually got two parts. This is kind of the piston spring retainer. And then here is the dished return spring that lays in there. You can see you install it with the dish facing down, and then the retainer goes in place. And this separates the C4 and C5 piston. And you can see this piston is in two pieces as well. When you remove this spring retainer, it has a return spring as well, and the dish is facing up on the C5. So the C5, the dish faces up, and on the C4, the dish faces down, and then the separator that separates the C4 and C5, the squared edge here faces down, and the tapered edge faces up. So now all of these seals in this input drum assembly, they are either O-rings or they're D-shaped seals. So you can go through and replace every one of those things. There are no molded pistons in this drum. Don't forget this small D-ring right there, or this medium-sized O-ring, or these two larger O-rings that we have inside this drum. You want to change out all those seals. They all come in the kit. Once you changed out the seals, we'll go ahead and put the pistons back in it, compress it, get the snap rings back in there, and then we're going to go ahead and build those clutches back up. So now we're going to go through and do an experiment on these clutches when we go back together. I actually have new clutches and new steels, and also have these used ones, which, and if you look, they look perfectly fine. I mean, there's no hot marks on the steels, the frictions don't look burnt or anything like that. They look good. So we're going to go through and do the clearance checks using these used clutches. And then we're going to go and put new clutches in them dry and do the clearance checks. And then we're going to put new clutches in wet and do the clearance checks and see how close they come to each other. And the reason why I'm doing that is because the process of checking the clearance is kind of unique in this transmission. As we've talked about before, what they like to do is you build it up, they put a load gauge and put a certain amount of force down on this clutch, zero your dial indicator, remove the load, stroke the piston, reapply the load, and then measure your overall clearance. And the reason why they're doing that is they're trying to take some of the slack out or the waviness or irregularities out of the clutch pack by placing a little bit of a load to begin with. They're not trying to flatten the wave plate. That would take a lot more than the 50 to 80 pounds that they have you put on it. They're just trying to, like if there's a little bit of waviness to a clutch or to a friction, they want you to flatten that out a little bit or just kind of take up that space. And then stroke the piston. I believe the reason why they want you to reapply the force is to take into consideration any deflection within your setup with the dial indicator and so forth. Every time we do this test, it really doesn't make a difference when we reapply the load at the top. So I want to go through and compare a used clutch set, a new clutch set, that's dry and a new clutch set that's wet. And also the reason why this is so important is because the spread between the low to the high of this clutch pack clearance is pretty tight. And some of these clutches is as tight as 19 thousandths, and they have 5 selectable snap rings to tweak your clearance. So they really want the clutch pack clearance to be pretty precise. It's because this transmission is a clutch-to-clutch transmission. There's no roller clutches, no sprags, no ratchet type clutches. So they've got these solenoids in the valve body and the valves controlling the release and the apply of these different clutches. And the computer apparently wants pretty precise knowledge on how much volume it takes to stroke this piston. So we're going to do that experiment when we go back together with this. This piston has these 2 little teeth there that fit into its own little notch. But don't forget that these kits actually give you new snap rings in them. So if your snap rings are a little distorted or have a groove worn in them or something weird, you got a set right there in your kit. So there's the snap ring groove opening, plenty large enough. And I've got a notch cut out here so I can use a screwdriver to kind of help me keep this snap ring when I spread it open, to kind of push it down in there and keep it from flopping off and fighting me. So in this experiment, we're going to look at the C5 clutch. And you can see I got some brand new C5 clutches and steels. And here are my used clutches and steels. You can see they still look fine. It's a pretty low mileage failure from what I can gather. And this is the adjustable snap ring to obtain the clearance. Okay, to start out with, we've got this clutch pack, the used clutch pack installed. And the first thing I'm going to do is I'm not even going to use air pressure. I'm just going to use hand force and lift up on it. And the first thing we want to do is push down a little bit on it so we can zero our dial indicator. So I'm getting 0, and I'm going to lift up. It goes up to 55 thousandths. So using hand force, I'm going between 0 and 55, pushing down a little bit and lifting up a little bit, or, to the snap ring. I'm getting 55 thousandths. Next, we're going to do the same test, but we're going to use air to lift that up to see if hand force lifting up makes a difference from air pressure. All right, so now we're going to use air pressure going through this fancy adapter. We're going to let 50 psi lift that piston up. We're still going to go through and push down on this with our hand, zero out the dial indicator. And now we'll just use air pressure to see if that makes a difference versus hand pressure. 53 to 55 before. And we got 55 thousandths. Okay, now we're over at the press. And it's because my fixture is not big enough to do this. So I got a little spacer in there so I could push down on the plate. And I got another little cookie cutter there, and this is a load gauge. And so first thing we have to do, according to the service info, is apply 80 pounds of force. It's pretty close. And then we zero our dial indicator, which is pretty much right there. So what they've had us do here is we put a specific amount of force on here to kind of take away any of the waviness and irregularities in this clutch pack. Then we zero our dial indicator, and then we remove our load gauge. Now we're going to apply 50 psi of air and stroke this piston up. And you can see we've had about 8 thousandths of deflection. And it looks like this went up to 62 thousandths. But what the service manual wants us to do is reapply our load. We'll see if that makes a difference. And it looks like we've got about 57 thousandths clearance. So really it's not that much different from doing it by hand or just putting hand pressure and using air pressure. All three methods get us pretty close. I think we ranged maybe from 54 to this is the highest, which is 57. So that was all with a used clutch pack. Let's go in and we're going to put a new clutch pack in there with dry clutches, and we'll see what it measures out to. You can see I've got about 12 thousandths deflection with this new clutch pack just by pushing down. But then pushing down, zeroing it out, and then lifting it up, I'm getting about 54. Not too far off of that used clutch pack. Same test, but I'm going to use air pressure now. Got about 12 thousandths deflection. Apply air pressure to it. I'm at 56 thousandths. Here we have this clutch assembly, and it's the dry clutches, never been used. And the first thing we'll do is we will put our load gauge. You see we're reading about 12 thousandths. This takes about 75 pounds of load. Okay, with this clutch we've got 75 pounds of force on the clutch. We zeroed our dial indicator. We remove the force gauge. You can see our deflection's about 8 thousandths. I put 50 psi of air pressure in it. You see we get about 60. And then we reapply our force gauge. And we're still at about 61 thousandths. And that's what the end play on this clutch is. Do it one last time, but this time we soak our frictions and see if that fresh transmission fluid is going to affect that end play measurement. Okay, now we're at the point where we have got our soaked frictions, and we're going to go through and do that test. See if a little bit of trans oil is going to end up making a difference in our measurements. So with these frictions soaked, I'm pushing down, deflecting it. Looks like it's got about 8 thousandths still of deflection there. When I lift up, get about 52 thousandths. $51 or $52. The same test, but this time with air pressure. So that goes up to 55. Same test, but with air pressure. Here we are with the wet clutches, 75 pounds of load, 0 dial indicator. I will release the load gauge. You can see the deflection's about 7 thousandths, 8 thousandths or so is how much it moved. Now we put air into it. It went up to about 60 thousandths. And we reapply our load. And it didn't change much, so we got 60 thousandths. So regarding the C5 clutch, it makes a little bit of a difference depending on how you test your clutch back clearances. If you're a traditionalist and just pushing down and lifting up, or if you're pushing down and using some device to lift it with air pressure, or if you're doing what the manufacturer says and actually use a load gauge and a specific amount of force down, lift it up, and then reapply that force. There's a slight difference in all those procedures. I think they all would work fairly well. I guess the key factors is if you're on the edge of a limit. If you fall in the middle of the spec, I think any of those methods would probably work fine. I do think that checking this with air pressure is important. I think it's better than just going through and just simply lifting up and down. The amount of force that you put behind the piston is pretty substantial when you put 50 psi in there. So any irregularities, it's going to take that out and it's going to lift that thing up solidly. And that's going to get you the most accurate measurement. Plus the air test tool is going to do a good job of checking for leaking seals or cracks or anything like that. If you're checking it through the front cover assembly and you're just using air pressure, you're going to be going past Teflon seals, and those Teflon seals might leak. And if those things are leaking, then you don't know if it's a leak from a piston or a crack or a seal or what's going on. So this eliminates that. It should be a tight seal, no leakage whatsoever. Okay, we are going to go together with our C4 clutch now. Our C4 clutch has a wave plate, a thick apply plate, 5 frictions, 4 seals, and then a backing plate. It also uses this apply ring, and you can see it's got these 2 little notches, and they fit into a notch inside that piston. On this clutch assembly, there are 2 fat teeth on the steels and on these apply plates, and they match up with the wider slots in the drum. These friction discs measure out to be about 62 to 64 thousandths. And the steel plates measure out to be about 95 thousandths. This spline right here does not have a notch for the snap ring, so you have to straddle the opening of the snap ring around that notch. So I'm going to spare you doing all these measurements on these different clutches, the C4 clutch, and the process is pretty much the same. So what we're going to do is I'm just going to show you the summary of all the different results that I came up with there when I did this little experiment. And as you can see by looking at this table, that's pretty much all the measurements were pretty close to the same. Matter of fact, if you did, especially the clearance with using an air tool, I think that's pretty accurate. If you were to hit the middle of the spec, or maybe on the low side of the spec, I think that would be ideal. If you're on the high side of the clearance window there, it'd probably be worth going through and getting a snap ring and lowering that clearance down to the middle or lower end of the spec. They're only like $2.50. The snap rings are cheap, last I looked, and I mean literally every snap ring but one was in the $2.50 range. So it'd probably be worth going through and getting an assortment of those just so you can hone in that clutch pack clearance and make them perfect. Now we're going to look at this C3 clutch. In order to work on it easier, I'm going to take the input shaft out. There's a thin snap ring that exists right here. Once I get that out, I can pull the input shaft out and it'll lay flat. It'll make it easier. I can use my screw press to take it apart and all that good stuff. So here's the C3 clutch. We've got 4 steels, 4 frictions, and a backing plate. Spring retainer, then there's a spring. The spring was revised at some point. And here's the apply piston. Got a D seal right there. And 2 others on the inside of the drum, a large one and a small one. On this drum, they also have the tone wheel for the input speed sensor. There's a bushing right here and a little roller bearing right there. You're going to want to pay close attention to and inspect those for damage and wear. Don't forget, they give you new snap rings in the kit. So that drum's pretty easy to come apart and go back together. First, we're going to build it back up with the stock parts. And as you can see, there's nothing wrong with this transmission's clutches. Everything looks good. The steels measure out to be about 110 thousandths of an inch. The frictions measure out to be about 70 thousandths of an inch. This snap ring is 112 thousandths. This is where you're going to have to straddle your snap ring opening, right around that notch. It might be a little hard to get your hands in there to do an end play, so using air pressure is probably the best way to do it, for sure. So this tool right here is going to allow me to place air and stroke that piston in that drum. It's basically a chunk of aluminum with a couple O-rings on it, cross-drilled, so that way when I put my regulated air into here, 50 psi, it'll get through this passageway here, get captured by those sealing rings, and stroke that piston. Now this is a homemade tool. GM makes their own version of this. They were on back order, so I had to make mine. But and you can make your own if you have a lathe. I'm going to go ahead and use my screw press to do this whole three-step process here that we're kind of doing with these clutches. Mainly because this is relatively thin and I don't feel like clamping my vice grip to it. I mean, it's not bad, but this has got a spline with that input carrier shell, so I don't want to mar it up at all. So if I do this, I can clamp it on the side, my dial indicator on the side of these. So I'm going to do all the measurements on this, so we'll just do all the comparisons here. So here we are at our screw press. We got the C3 clutch housing with the clutch in there, and I got my dial indicator sitting on the backing plate. You can see I'm not zeroed out yet. I'm not using the screw press at this point. I'm just basically utilizing it so I can mount my dial indicator to it. First, if we kind of push down on it to kind of figure out how much deflection we have, pretty close. Then if I grab a couple picks, we'll first start by doing this by hand. I'm going to go underneath these clutches and pick them up. Looks like I'm getting 78. Push down and lift up. 78. And now we'll apply air pressure, 50 psi, and see if that changes the measurement at all. From 0, got about 82 thousandths, 82 or 83 thousandths. At this point, we have the C1 and C2 clutch installed. The C1 clutch has its proper clearance, and now we're going to go and build this gear set in here. Got this plastic thrush washer that goes below this input carrier assembly. There's a plastic thrust washer on top of that input carrier assembly. And now we'll put our plastic thrust washer on top of that sun gear, as well as the Torrington bearing. This provides a surface for the Torrington bearing to ride on. If you look, there's these teeth, these small teeth that fit around the splines of that sun gear. And the teeth don't go all the way across. You want to have this flat surface here facing up towards that Torrington bearing. Now they do give you this plastic thrust washer in the kit, so if this thing is marred up or it's got grooves or cracked or anything like that, definitely replace that. I'm going to take this input drum and I'm going to kind of preload it with these different gear set parts and tilt the transmission to the side, and that'll ease the assembly. So I'm going to start here with my direct and overdrive internal gear assembly. And I've got my Torrington bearing on there. That's going to protect it up against the input drum there. Next, I'm going to do my direct and overdrive carrier assembly. There's this Torrington bearing right here, this large Torrington bearing that contacts that direct and overdrive internal gear, and this is where the sun gear is going to contact. And next I got my input internal gear assembly. This input internal gear assembly has the second planetary gear set's internal gear, but also has the front planetary gear set's sun gear. I'll drop that on. This portion right here is going to contact the Torrington bearing inside the planetary gear set. So at this point, I can go ahead and tilt this transmission to the side, grab this whole assembly, kind of just finagle it right on in there. No clutches to line up, you just have to get those gear sets to spline together. Now I'm ready to put my C3 clutch assembly, put it into the transmission case. Before that, I'm going to take my spacer here and my Torrington bearing. I'm going to place those in the input drum assembly here. Now we just got to put our C3 clutch assembly in. spin that in by hand. That dropped right in there. Now if we take our thrust washer and our Torrington bearing and place them on top of this C3 clutch assembly. Okay, so now this Torrington bearing right here lays in here like that with the outer race, what I would call the outer race, where it wraps up around, facing towards these tabs. Now you know if you have this in all the way, if when we go to place this front support assembly in and we drop it down in there, that this portion, the ceiling portion right here, lays flat right along the portion that it's supposed to bolt up to. If it spins like a turntable, if it spins real easy, then you know this isn't sitting flat down onto the case. It's being held up by something misassembled. So we'd want to go through and take it apart and figure out what we've got in there, either upside down, backwards, wrong, or maybe we just don't have our clutches lined up all the way. So you can see this thing sits nice and flush and it does not spin like a turntable. If this was sitting up, this part would spin much easier. Of course, before we would install this, we'd want to make sure we change out these little seals right here if needed. We'd also do a good job of inspecting our bushings. There's another Teflon seal here. There's a thrust washer, a plastic thrust washer. All those parts are included in the kit. It's always a good idea to take a look at these sleeves right here, make sure these holes that they're supposed to feed are opened up and they're not closed off. Of course, before you tighten anything, as you're snugging things up or drawing bolts in, make sure that input shaft spins. Now when you go to tighten down this front stator support, you're supposed to tighten that down to 26 foot-pounds. And there's actually a torque sequence. And I'm sure you can get by with just doing a star pattern perfectly fine, but if you were to follow the service manual, they'd have you go 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. So you're basically making triangles and then rotating that triangle around clockwise. Starting with this number 1 bolt, which actually has a little casting right there, which I assume maybe is to let you know this is the number 1 bolt. When checking end play, which this would be a good time to do that, they kind of take notes off of their fancy clutch pack clearance measurements. They want you to push down on this input shaft and then lift up on the output shaft. Now they've got their load force, they want 50 pounds of load here, and then they use a screw attachment on the bottom to lift everything up. In reality, I think you could just get away with pushing it down with your hand, zeroing in the dial indicator, and then lifting it up with your other hand. Push that whole assembly up. And I'm probably getting about 16 thousandths of an inch. If everything's looking good, we can put our new gasket down in there. Now before we put our front cover back on, and after we put our gasket on, we need to put our chain and sprocket in place. Now when we go to put our front cover on, don't forget, we've got a replacement thrust washer, and we need to replace that front pump seal. We've got this nice big massive gasket right there. With these bolts, you're going to want to have a little bit of thread sealant on there because you don't want automatic transmission fluid to find their way through the threads and then create a leak towards the front of the bell housing assembly. So there's going to be a little bit of resistance to overcome that big O-ring on the side. If you put a little bit of TransGo on there, that'll help slide that in there easier. But you don't necessarily want to just pull those in with these bolts. You don't want to crack that cover. So you can use the handle of a hammer to help tap that in while you kind of draw in the bolts a little bit here and there, kind of work that seal in there. So all good is just a little bit of tension on these 10mm bolts. And you can look at the gap around this bell housing and around this pump cover to get an idea if you're pulling this thing in or if this thing's going in evenly or if it's kind of going in crooked. When you're putting this thing together and you're putting the front cover on, make sure the chain is not in this area between that stator support and the front cover, that gap right there. It's pretty easy to do when you're bolting this thing all up and pulling this thing down and you don't realize it, but that chain link might be right underneath this area, this little boss, and obviously it's going to bind it up. So you want to make sure that this is free and clear. Matter of fact, you can grab that chain and spin that pump gear. Now these bolts get torqued to 84 inch-pounds. So you don't forget later, now would probably be a good time to slide our seal on for our torque converter. So at this point we got our gear set all built up, we got our end plays where they need to be. Now it's time to finish it off on the valve body side of things. Now we can go through and also air check this before we put the valve body on, so we can go through and ensure that all of our clutches apply with 30 or 40 psi of air pressure. Now it's time to put some of this parking pawl mechanism in here. This is a component that GM just over the years has not been able to seem to get right, it seems like. And so pay close attention to the parking pawl components. Make sure there's no wear, because there's a service bulletin out that has you address these parts if you've got a vehicle that does not want to go into park. New roll pins do come in the kit. Replace the O-rings on the pass-through connector. Make sure you change out these speed sensor bolts. These come in the kit as well. So the speed sensor bolts and the fluid pump baffle bolts, those are torqued to 35 inch-pounds. And then another 45 degrees of a turn. So they're torque to yield bolts. So you get your torque established on there. And then you want to turn them another 45 degrees. And that's the way they want you to replace those bolts every time you take one out. This parking pawl bracket gets torqued down to 26 foot-pounds. Now a few other things that we could tidy up on the inside before we put the valve body down. These little wiring harnesses have little nubs that they have clips that push onto. Kind of keeps things tucked away nice and neat. We also want to put our bridge seal there. Don't want to forget that. And at this point we're ready for the valve body. Well, I personally think it's kind of easier to kind of hook the chain in place. But you can put the sprocket on afterward if you want. This valve body looked pretty good, so I didn't want to use this for the demonstration in the video because it didn't really show that many worn out parts. But what this does have that the other one doesn't have is this start-stop accumulator assembly. And if you read right here, it says contents under pressure, do not disassemble. And the kits, the two kits that I have, one from GM and one from Precision, I don't see any parts in there for this. So, and I've taken this apart, and I will take it apart here in a second, and there are a couple seals in there, as well as seals for this solenoid, but I don't see those included in the kit. So we might figure out a way to go through and test this, but you can take it apart, and I'll show you. You just have to be real careful because the spring assembly that's in here that keeps pressure on fluid that's in this accumulator, it's a pretty hefty spring. And if you just took these 4 bolts out right here, and you weren't thinking about it, by the time you get towards the end of the threads, this thing would probably pop out at you pretty violently. So pay close attention to this. Be careful if you do take it apart. There's a lot of fluid in there. I think it's very important to disassemble it myself. It's either replace it or disassemble it, so that way you can clean it out properly. Contents under pressure, do not disassemble. And this is the solenoid for it. So when the solenoid is activated, it allows fluid to leave this accumulator assembly and keep the line pressure circuits primed. That's how fluid finds its way into this regulator assembly. So line pressure unseats a little check ball in there and fills the circuit up with fluid pressure. And then when they energize the solenoid, fluid can come out of this passage and prime the rest of these fluid circuits. And it regulates how quick fluid can find into those circuits by these little orifices right there. The solenoid has a couple Allen screws to take it apart. Just some small O-rings sealing off those solenoids. But these are the screws you just don't want to take off without having pressure on this. So we're going to move over to the arbor press and keep tension on this while we pull this apart. There's a D-shaped seal right there, and these two plastic kind of guide rings, they're split. And the kits that I have do not include these parts. Which is unfortunate, because if you're careful, you can take this apart. This cover will only fit on one way. If you try to get it 180 off, it won't work. So it only fits on one way. Out of curiosity, I was wondering how much force is on that. So before I completely tighten this up, I put my load gauge on there. Just when I bridge that gap, I'm at about 350 pounds of force. So that's how much force is on that spring. These tiny solenoid bolts only gets torqued to 27 inch-pounds, believe it or not. It's barely more than 2 foot-pounds. One test you could possibly do is put air pressure into this little hole right there. I want this to fill up with as much pressure as possible. And then, in theory, it should trap that and not let any through. Then when you energize the solenoid, it should open that up and let it come out through there. Well, I'd say that tested out fine, so we're going to go ahead and put it back on. As I mentioned earlier, I find it easier to install this valve body with the oil pump sprocket already installed. I just tilt the valve body a little bit and fish the chain onto the sprocket. Don't forget to clip your manual valve. You want to make sure that valve body is sitting all the way down and it's not perched up. Last thing you'd want to do is tighten some bolts when this thing's not perfectly flat up against the case. The bolts that hold the valve body to the transmission case use these external Torx Plus, and there's two different sizes, so it's pretty hard to get those mixed up. So for all of these bolts, we have two torque specs. Anything that uses this external Torx or an 8mm headed bolt is going to get 80 inch-pounds. And anything that uses that 7mm headed bolt is going to get 71 inch-pounds. If you remember when we assembled this valve body, we kind of snugged up these bolts, but we didn't bring it quite up to torque. You want to do all of these bolts to torque once you have this valve body installed in the transmission. Kind of like the speed sensor, these baffle bolts are made out of aluminum and they are to be replaced. They come in the kits, and those get torqued to 35 inch-pounds plus 45 degrees of a turn. The spring detent actually gets torqued a little higher than the others. It gets torqued to 106 inch-pounds. Now it's time to clip in our wiring harness. This harness at some point did get upgraded because of this temp sensor. And lastly, we have our oil filter. Make sure that seal is installed in there. We'll put a little TransGel to help it squeeze in there. And we're finishing up with our pan gasket. Well, that about wraps it up for this transmission. It was pretty easy to take apart and put back together. There were a couple special tools here that I used in the process. All the other ones that aren't shown here were pretty generic that you probably have laying around in the shop. I do recommend getting some tools, either making them or purchasing the OE tools to go through and air check these drums. That way you can be positive that these clutches or these clutch drums don't have leaks, either through their seals or through cracks or anything like that. And then you can also use them for doing their clutch clearance measurements. Thank you for watching all the way to the end of this assembly video. And the next video you should watch is the valve body video, where I go in deep into this valve body and I describe how it works and I describe some of the modifications that are done by the different aftermarket companies.